An ion is a charged particle, that is, a charged atom or a charged group of atoms. Anions are negative ions, whereas cations are positive ions. The reason that an anion is negatively charged is that it has more electrons than it does protons. And an anion is formed when atoms gain electrons. So I'm an atom, I'm neutral. If I gain an electron, I'm now an anion. I have a net charge of -1. If I gain 2 electrons, I'm an anion. I have a net charge of -2. Cations, on the other hand, are positively charged, which means they have more protons than they do electrons. And cations are formed when atoms lose electrons. So if you are an atom, you are neutrally charged. You have the same number of protons as electrons. If you lose an electron, now you have 1 more proton than electron, and so you have a net charge of 1+. In other words, whenever we form ions, we either gain electrons or we lose electrons. We never gain or lose protons. And that's because the protons are buried in the very center of the atom, and they are very tightly held together. We can't pull protons out very easily and chuck them into the backyard and lose a proton, because those protons are held together very tightly. Similarly, we can't bring another proton and stuff it in there very easily, because the nucleus is positively charged with all those protons, and if we try and bring another positively charged proton up close, the closer we bring it, the more those two don't want to get together. So, whenever we form an ion, it's because we're either gaining electrons, in which case we become an anion, or we're losing electrons, in which case we become a cation. Here are a few things to help you remember. Anions are negative ions. You can see that there's a little relationship there. Anions are negative ions. When I see a cation, I see a positive ion. That is, I see a positive ion. How clever is that? See that? There's a plus sign right there in the word cation. When I see a cation, I see a positive ion. Furthermore, in case you're wondering what that is a cation of fish. Alternatively, it's a cat keeping an eye on a fish. Okay, I don't think that's going to help you learn chemistry, but anyway. These are the polyatomic ions that I ask my students to memorize. Take a picture of it on your phone if you want. Ionic compounds, or salts, those two terms are synonyms, consist of oppositely charged species bonded by electrostatic forces. You can describe salts as metal-nonmetal, but cation-anion is better. Nomenclature of ionic compounds. A chemical formula has a neutral charge for a compound. It shows the type of atoms and how many of each. To write an ionic compound's formula, we need 2 things: the 2 types of ions and the charge on each one. So in this first example, we've got Na is a 1+ and F is a 1-. If I put one of each of those together, that's going to give me a neutral compound. The next example, a Ba is worth 2+, O is worth 2-. If I put one of each of those together, that would be a neutral compound. For the next example, you can see that each Na is only worth 1+, while the O is worth 2-. So I need 2 Nas for every O. And in the last example, hopefully you can see I need 2 Fs for every 1 barium ion. Parentheses in a chemical formula are required only with multiple bunches of a particular polyatomic ion. So if we want to pair these up, we can see that the barium ion is worth 2+, this sulfate ion is worth 2-. So I need 1 barium and 1 sulfate ion. No parentheses, because I only have 1 bunch of sulfate ion. In the next example, this is the magnesium ion. This is called the nitrite ion, NO2, with a 1- charge. Hopefully you can see that I'm going to need 2 nitrite ions to match up with my 1 magnesium ion. So I need 2 bunches of nitrite, so I use parentheses with a 2 on the outside. Here I have the ammonium ion, and this is called the chlorate ion. Ammonium ion is a clump of 5 atoms with a net +1 charge. The chlorate ion is chlorine and 3 oxygens. That's 4 total atoms. That clump has a net 1- charge. 1 clump of each will be perfect. The next example, I'm going to need 2 sulfate ions to match up with my 1 tin 4 ion. So we write it as follows. In the next example, we have iron 3+, and then this is called the dichromate ion. It's a clump, as you can see, of 9 atoms, and that 9-atom clump has a net charge of 2-. In other words, that clump of 9 atoms has scavenged 2 electrons from somewhere, which means if I want to match these up in the correct ratio, I'm going to need 2 iron 3 ions and 3 dichromate ions. Since I need multiple bunches of this polyatomic ion, I represent that by putting the entire polyatomic ion in parentheses and then say how many on the outside. And the last example, I'm going to need 3 ammonium ions to match up with my nitrite ion. Let's summarize our introduction to ionic nomenclature. 1. An ion is a particle with an unequal number of protons and electrons. Anions have gained 1 or more electrons and so have a net negative charge. Cations have lost 1 or more electrons and so have a net positive charge. 2. A polyatomic ion is a covalently bonded group of atoms that have an unequal number of protons and electrons. 3. Ionic compounds, or salts, consist of cations and anions ionically bonded to each other. And 4. Parentheses are used in chemical formulas only when we have more than 1 clump of a particular polyatomic ion.